Well, good afternoon. Welcome to our workshop on the phytosanitary risk reduction estimation model. My name is Rick Dunkel, and I'm the Senior Director for Seed Health and Trade with the American Seed Association. Our workshop is going to be presented by Dr. Drew Posney and Wiki Lee. And very quickly, Drew and Wiki are researchers at North Carolina State University with strong backgrounds in plant pest epidemiology, advanced modeling methods, spatial algorithms, and quantitative risk analysis. Drew has an extensive background in mathematics and infectious disease modeling. Wiki gained several years of experience in applied mathematics and statistics at the Food and Environmental Research Agency in the United Kingdom before beginning research in Florida on citrus pests, particularly the dynamics of HLB or citrus greening disease and the Asian citrus psyllid, which is the vector of HLB. Together, Drew and Wiki develop innovative sampling designs and analyze mitigation strategies to maximize pest and disease control at multiple scales and inform management decisions. They lead the development of many web-based applications and information systems for pest and disease modeling, pest surveillance, and disease simulation and risk analysis. These two have been the primary architects of the new phytosanitary risk reduction estimation model, which was developed as a joint project with Iowa State University and under the tutelage of the American Seed Trade Association as a sponsor. So with that, Drew and Wiki, I will turn it over to you. Thank you.
Okay, great. Thanks for that introduction, Rick. My colleague Wei Lo is on this call as well, but I'll be starting us off. So good afternoon to everyone. I hope you all can hear me and see my screen without any problems. I need to move some things out of my way to begin. Okay, so today Wake and I would like to talk about the phytosanitary risk model, some of the updated features that we were able to make to help address some requests from the industry and ASTA to kind of cater the tool toward more practical applications and direct usage for different seed companies. And then we're going to try to do some demonstrations. Usually, especially in a remote setting like this is something we'd rather do in-house. And keep in mind, there's usually technical difficulties, but we will do the best that we can and share the link with you guys later and hope that you go out and check out the different updates that we've done. The other thing I want to mention right off the bat is please feel free to interrupt me, ask any questions throughout the presentation. I think there's a chat box somewhere in here, and we can address any other comments or questions as we go. So to begin, I just want to give the brief structure of how I'm going to do this presentation. So we have several components that I want to touch on. First, we just want to give everybody a brief background, about the model, kind of its purpose and the project goals and the kind of applications that we wanted to gain from this model development. Kind of doing this because there's, I think, a wide audience here that may have not been on any of our previous workshops or presentations. So we just want to set the stage a little bit about the model. Second, we'll go over kind of that development process. Again, gives you that sense of the framework and how the model was built so you can peer into the guts of the model. And then we're going to spend some time with the platform, the web-based tool that we have. We'll start by giving just kind of an overview of it, some screenshots and a couple of the different things that have been updated with that platform. And then we'll look to kind of live demonstrations. Again, that could be the tricky part, but we'll do the best we can. And I just want to point out that it's recommended to use Chrome, Firefox, or Safari, mainly because Internet Explorer is kind of limited in its functionality. We are correcting this, but I think in general, they're moving towards Edge. So that might be a more appropriate browser if that's your browser of choice. And then we'll end with some kind of summary, some conclusions, just an open discussion about the next steps and different directions we can take with the model and the tool where we are now. Okay, so let's start with just the brief background. In general, if we think of it in just general terms, there are definitely many critical control points throughout the production process where pests and diseases can be introduced and also propagated kind of along that pipeline. There are definitely a lot of environmental factors or conditions that can make a production site vulnerable to invasions or introductions at different stages of that process. So what we have here, I'm gonna keep my train of thought going here, but we have pre-planting to pre-harvest to harvest. There are different mitigation measures and management practices kind of put into place at different parts of this stage. And the overarching goal is to reduce pest risk. So what we want to do is be able to break down this process and look at what's going on at each stage and kind of quantify that risk, both in the simple stage phase and as a whole comprehensive system. And so there are a lot of different measures that are intended to reduce the risk, but we want to kind of evaluate that part. The other part that we have is a seed health testing kind of node in between here. And this really just provides a mechanism to remove contaminated seed from the system. It doesn't really affect your overall phytosanitary risk, but it allows you to take some of that out. So we have that inserted after harvest, and then the seed would continue on to some sort of post-harvest processing and conditioning operations, and then potentially followed up by another round of testing before moving on to trade and being transported or stored and distributed around the world. So this definitely is a simplification of the complex process, but it helps us as modelers to break it down into these piece parts. And there's been a system in place where seed companies and decision makers look at these critical control points and different hazards to see where we can implement different practices. So building upon that, so that's something that ASTA has definitely been a proponent of in some of the international phytosanitary standards. They're looking to a hazard analysis and critical control points kind of concept. And they do this they use this for their risk analysis. So the model kind of started here. It looks a lot complex and it's very busy on some of these sections. And so it is built in its entirety a few years back, but it was built as a probabilistic model that analyzes management practices on phytosanitary risk. The focus of this initial model was on CMM of tomato. And like I said, it looks complex. There's a lot of different parts here that we can kind of move and separate out. And it's not completely intuitive in its design to be directly implemented by an end user, say a production site manager or any other agency that's looking to make decisions about mitigation practices throughout the entire process. So what we have been doing the past few years is breaking this down a little bit further and kind of using that flow chart system that I showed in general terms in the previous slide. So we can start to piecemeal this back out and get some sense of the logic behind the pathway structure so that it follows the true mechanism or the true production system. So in this kind of thing, it kind of matches a little bit back up with that flow chart. So we have, if you look at the blue nodes in the middle, that kind of gives us a sense of the overarching category or phase of this production pathway. So in pre-planting, we can look at kind of the site type that we have, what's the pest or vector population. There's a lot of different things, but in this format, it's easier for an end user to break down and look at, well, let's focus just what's on pre-planting at this point, and can we evaluate our system in this stage? and then move on to the next phase as we go. Instead of looking at it as one big group of nodes, this just makes it that more intuitive to pick up. But in the other sense of this, instead of having that big, kind of somewhat ugly graphic, I wouldn't say it's too ugly. There's a lot of mathematical concepts behind it. But in that kind of graphic, what we can do now is isolate these kind of color-coded categories and focus just on that section. And then we can quantify the risk of the phytosanitary risk, say in the pre-harvest stage. And then as well as it propagates through. So we can start to divide it up and see where things are more risk or vulnerable, or more vulnerable, and where we can identify issues quickly that need to be corrected. So this just kind of helps us to break it down into pieces in a more logical format. So with this model design, we had a few expected outcomes for the development. We wanted to present a formal procedure to quantify and assess the steps in the system as I've laid out in the previous slides. And we also want to continue to evolve to incorporate more details of the production system and the different interventions into the model. So it's one of those types of models that's constantly learning and taking in information to be refined. And again, more useful in terms of a real world application for seed companies. In essence, it really does serve as a tool to analyze quality management programs and, like I said, identify phytosanitary issues quickly. And the key factor is we want to numerically test management programs or what if scenarios, such as changing some practices, whether that's a budgetary adjustment or just in general, we want to focus on different interventions. So this gives us that quantification that I think was somewhat missing in some of the risk analyses previously for seed health. Okay. So that, if there's any questions, I'll keep going. But that just sets the stage, like I said, for what the model was built to do. Now I want to kind of get into a little bit of the development process. So as I mentioned, it's built off of those hazards and control principles. So there are definitely many variables that are risk propagating and variables that are risk mitigating. And those are your management practices. One of the key problems we had when developing this model is that most of those variables don't actually have data behind it. So we can't have a ready-made model already populated right off the start. But what we can do, or what we did, was look to addressing and defining the different relationships between each variable. And this is how what we did to kind of start populating and developing that model. And this mostly, or if not completely at this point, relied on, expert knowledge and experience to define the variables, identify the relationships and the associated risk as they kind of interact and what that mechanism truly is. And we do this until we get enough data. So far, we have not a lot of data to really add to the model as it currently stands. So we keep relying on asking and requesting and talking with experts in different positions within the industry to make sure that the model is well defined and it's connected in biologically feasible relationships, and that it's valid when we look at the different types of scenarios and outcomes that it would produce or estimate. Okay, so just to dig one further step deeper is to look at how we address getting that information, and that's through an expert elicitation process. The main thing I want to point out here is we don't rely on just one expert commanding the model. That's not entirely correct, right? And it needs to be, like I said, well defined. So instead, we are always looking for other experts across the industry to provide feedback about their knowledge and experience and help refine these model components. So in an ideal world, we get everybody in the same room, discuss each variable, all the relationships, and the associated risk, and they'd all come to an agreement, and then we'd be good to go. This really just isn't practical or easy because the whole point is coming to an agreement, and that takes time and conversations and discussions. And then you build a model, and then there's always something more we could do, right? We can make it more complex, we can make it more detailed. So in an ideal world, we could do this, but this is why it's a constantly learning and improving model design. The other issue with this is if we're looking to an exotic pest or disease that we don't have a lot of information about, it's still new to a lot of people in the industry, or it's just not well understood. This is one of those things that will help us to start to build that model and kind of learn more about it as we, actually learn more about it. So that's kind of where we are with that. So we've taken a few different approaches for getting feedback to feed into the model. We have online programs, we talk on the phone, we have conferences, we do questionnaires and offline forums. And then we hold workshops kind of like this to just talk with a group of people all at once. And okay, now we're going to take one further step into that. So what does that actually mean, right? So if we had a particular variable, this is not listed, but let's claim that this is climate conditions, and we want to know about how climate affects contamination probability in a seed production system. So we could ask a panelist or a variety of experts about the probability that if climate is favorable for a pest, what's the likelihood that an introduction or invasion of that pest would happen? And they provide, a feedback. It can be a wide ranging of information. Maybe they're a little unsure of, the exact quantification of that question. And they're also allowed to provide some confidence with their answer. So you can see whether or not this group of experts over time have any kind of agreement about this particular variable and the questions that are asked. One difficult, or I wouldn't say difficult, it's challenging. One challenge with this is that in the framework of how the model was initially built, we're looking at variables as individual points. So when I'm talking about climate conditions, it might be easy to ask this question and also consider whether the pest is actually there or not, or whether or not the production system's within a greenhouse or it's an open field. And that would tweak some of these answers. So you're looking at a scenario or a combination of factors versus just one. And so that can get complex as well, right? So if I wanted to ask about climate conditions and whether the pest was present, is there a history about the disease in the area? Are there other alternative hosts? That really makes a challenging question to answer. And then considering the intensity of each one of those conditions. So in general, we always have to kind of scale back to one individual component up front. And sometimes that takes a lot of effort to get our brains wrapped around answering that type of question. But we do this because the model can look to and incorporate inside the algorithm the combination of the factors. So that underlying algorithm actually accounts for these scenarios. And there's uncertainty with that, of course, but it allows us to kind of refine and scale down the elicitation process to individual components. Once we start to gain more of these factors, we can then look at the scenarios that an expert or an individual panelist can consider and look at that combination and see if it's in line with their experience. So there's ways to look at that scenario combination down the line when we get feedback about the model construction and validation part of it. But up front, we have to kind of pinpoint and target a particular question about each of the individual variables, because that would just add a lot to the discussion, and we'd be here probably still working on the very first model, looking to all the different combinations and relationships and deciding whether that's biologically sound or in line with a different person's experience that might be considering a different factor all at the same time. Okay, so I've rambled a little bit here, but let's get back to this example here. So we can look at the confidence level that's self-identified. An expert can also provide comments about their experience to help us understand why they came to the response that they came to. But what our goal here is, so that way can I do in the background, is we have to take this information and aggregate it. So if there's a difference of opinion, we need to go back to those experts, just like I said, to discuss how they got to their answer, and if it's dramatically different than another expert, so we can have that follow-up discussion. But what we do here is we're going to take all of these expert opinions and experiences with this particular variable and aggregate it to something that looks like this. So these are weighted based off of the self-identified confidence, and using kind of this algorithm in the background that compiles it, right? So let me go back to this slide. So we have a lot of agreement right up at near the 90 to 100% probability. So that's why we have this skewed distribution here, closer to the high risk area. So what it's doing, going on too many slides, it's taking each individual and creating their own distribution, and then we weight them together based off of the confidence level through this statistical process to get to an aggregated or a cumulative distribution. I'm trying to keep this a little bit overview, but I can definitely go into the details if somebody wants a little bit more information. So we do this for all of the model variables, right? So each individual model variable will have this kind of risk distribution associated with it. Okay, so we still need to link that back into what the model does. And so for right now, let's just look at the very first row of blue distributions. So basically, if I go with my climate suitability example, pretend that this blue distribution looked exactly like this one, because that's what these blue graphs are doing, okay? So what we're gonna do with the implementation and the link to the model is to actually take a Monte Carlo simulation approach, and this allows us to run thousands and thousands of iterations or simulations that will pull information or points, you see these red dots, from the distributions. Now, depending on your production system and your management program that you input into the model, the algorithm actually adjusts how these red dots are pulled from the risk distributions. So if no information is actually given about your production process, the red dots, or the weights that we pull using this, will give the full distribution. So a lot is just unknown, so it's almost like sampling at random. And then each one of these rows would be an iteration. We get a risk output, and you'd have a distribution of estimated risk. So we collect the information from every variable. There's definitely a lot more listed here, but this is a quick and dirty example of pulling from 3 variables. And you would do this at each stage of the process, and it gets propagated through the whole pathway. And so then we'd arrive at a final risk distribution at each stage, and then a final estimated phytosanitary risk output. Okay. Again, trying to do this quick. The important takeaways that I want to make sure to for you to take home is that the model was definitely built by you all and for you all. So we're always looking to get more feedback about what's going on with the model. Do we need to refine something? Are there pieces where information is insufficient or not biologically feasible based on your experience? And then also some validation with that. So like I said, it requires feedback from experts across the industry, not just in one particular field. And with this model, we originally focused on 3 pathosystems, a fungi, a virus, and a bacteria. And so we started with a direct model for these three. And since then, we've been looking at what's common amongst these pathosystems to build a general pest model. And so that's what we're kind of going to show today is the generalization of these to get to allow users to run it for any pest. So there was a lot of overlap between practices, and that's what we were taking. And the only limitation with this new design is that there is greater uncertainty with the general pest compared to the ones that are targeting a particular pest. Okay, so that is the brief overview and description of how the model was built, what it was built for, and the process behind the scenes. Like I said, there's a lot more details that I could get into and different mathematical and statistical algorithms to show you. But to keep it light for everybody and hopefully in a condensed version that's easy to digest, that's kind of that summary. So in the next part, I want to spend some time kind of looking at the new features that were requested and the updates for the online platform. See my mouse work? There we go. Okay, so there's been, if you participated in a workshop, there's been a lot of different iterations. And we do this mainly because as modelers, we may see things slightly different than what is practical for a seed company. And so we're looking at, we initially started at that kind of plain, very complex Bayesian network framework that Wakey and I can easily understand and comprehend, but it needs to be kind of user-friendly and applicable in the real world. So there's been several iterations. The other part of it is the terminology we use might oversimplify or generalize a particular practice. And so these things need to be refined so that it's more accessible to seed companies and decision makers. So we definitely have a few iterations. Some things are good, some things not so good. But I want to touch on the primary goals of the online tool. Just like the model was built by you for you, we want this to be, for you as well. So the key goal for this is just building a platform to help you evaluate seed health management programs. So that's kind of the overarching goal that we want to do with the online version. And we want to keep it straightforward and easy to use. And we want to continue to curate it or tailor it to what is actually needed by the industry. And the other part is to provide some quantification. We want to provide quantitative phytosanitary risk output that kind of goes with the qualitative approach that's usually done for the management strategies. The other part that the online version gives us is a quick visualization, and we can quick test different changes without having to take on that burden of the fiscal side. Right? We can look to changing our practices slightly and see if that will benefit us enough to make that change. And then finally, we want to be able to generate some sort of output. So there is definite room for improvement with this, but we want to generate an output that actually can accompany different management plans or be of practical use as you go through your seed production systems. Okay. All right, so this is the new landing page of the online system versus my crazy node network that I think I spend more time just moving around in the screen, but this kind of condenses and kind of creates very big buttons for you to quickly go to the place you want to go to, right? So it starts with just looking at the phases we currently have enough feedback and information about for a general pest. So these are all buttons that you can interact with. So we could go to the pre-planting phase, a pre-harvest category, and a post-harvest category. So that's kind of our main pieces for now to get a phytosanitary risk. This is not available, storage and distribution, because like I said, we're missing a little bit of information to make this available to you all. And then we also have a seed health testing part where we can remove seed from the system. And then the last part in red is your output, so that it's broken down and we can easily jump around to the different categories to investigate. So in the next few minutes, I'm just going to walk through some of clicking on these buttons, and then we'll pull up a live demonstration if possible. But okay, so if we click on, say, pre-planting, what happens, and you can see up at the top, I'm going backwards just a little bit, that there's tabs. So you don't have to use these buttons, but we'll be moving through the tabs that are up at the top of the screen as well. So it's moving us to our management plan. And so the buttons now have turned into these other kind of file folders or a subset of tabs. And we've broken down the phases or the categories into kind of these subsections. So in pre-planting, we're looking at everything before the seeds put in the ground, right? So there's room for improvement, but this is how we've currently categorized the subsections. And just looking at pre-planting, we can look at what is the prevalence of the pest or the vector in the surrounding region, whether or not the seed was tested before it was put into use in our production system. We can look at environmental conditions, back to my climate suitability, and in general sense, what's the soil system and the water sources at our site. And then we can look to the prep work for building up that site, if it's new, or what's been done to either isolate the site from nearby hosts and pests. Is it an open field versus a covered greenhouse, and the kind of cropping system we plan to implement, or what's our mode of operation there. So these are kind of the pre-planting nodes, and we can click on them. So we've taken away some of the sliders that we used to have to allow a little bit more flexibility in the responses posted for this type of survey design. Let me just focus in on pre-planting for right now. And so if I zoom in to this, just so I can talk through it, we have these two things. These are just drop downs for now, and it's color coded to help with, is it a risk mitigating versus a propagating answer, and what we might be able to do to improve upon that. And it comes with a little bit of information about our definitions here. So what we mean by the pest and vector prevalence and the seed origination underneath the drop downs. One feature that we haven't completely implemented, but I think would be helpful for an extension, is to include other mitigation measures that would go directly into a particular variable. So when we think of just what's going on in the pest and vector population, we might be actually implementing other measures at the same time that are not currently included in the model. So we might have some biological control that we want to note in this until we get to a quantification of what that means to adjust in the risk-based model. I know that's a lot to take in, but that's where we're hoping to go. But to go a little bit further, if we focus just on pest vector population, we can look and drop down about a qualitative approach to what does that mean for my production site. And here's the color coded. It might be none. We can have a low population all the way up to a very high. Some of these factors, such as this one, we can add an input, I'll say here, that switches it back to that quantification. So we might want to look to the pest prevalence in my area might be, high, but I want to, detail that a little bit more. I'd say maybe it's between, 65% to 90% of the time is in my area. There might be a room for that. We can definitely integrate that into the model, but if there needs to be more control over these answers, we can supply that for some of the parameters. And so we can click on whichever one that we want, and it reminds us of whether or not that was a good thing or a bad thing using just the regular traffic light system. And you could select these extra mitigation measures and continue on with that. But I think that's a place that you guys can play around with when we share the online application with you all. Using the big buttons at the bottom, we can step through those phases. So this was after we filled in all of pre-planting, we could move on to the pre-harvest. And it's broken down hopefully into more manageable pieces that all fit on the same screen without getting too crazy, where we look at particular points in the process. Is it relative to the personnel and operations? Is it some sort of survey that we're doing? And then a hygiene and sanitation kind of category where we can really pinpoint and target those different interventions. So everything also starts off as unknown because there's no information we can put into the system. And whether, if there's no room for an unknown, I think people know that there's a hygiene program that's an easy yes or no. It's not completely unknown. So those would always start in the bad category and you have to make changes. So all of this would get updated by you all as you enter in the information. And they all come with pieces of definitions and we compare more stuff with that. And as you click through, it'll go to the next stage. And again, it's broken down into different categories. The treatments, I want to point out, are kind of particular to the pest or pathosystem that you're looking at, but we list everything here. And so you can make those changes for whichever pest that you're aiming for. Anyway, okay. If we go on to the next button one more time, it also reminds us where we're going, but it'll go to seed health testing. And so right now, we've taken this kind of out of the model because it does not affect the risk of the seed actually being contaminated. But what we can do is decide whether or not we're going to test it at any point in the process. And if we click on testing it at some point in the process, we can address the laboratory conditions and operations that would help us to remove any contaminated seed from the system and from the pathway, and then incorporate that into the final assessment. But for now, this is just here to kind of test whether or not this is useful to you all. I think if Gary's on the phone call, I think he would agree that it's very useful. So anyway, the final risk map or final risk assessment, excuse me, is at the last tab, so you can automatically jump to it. But it's easier to work through the system and it's the right pathway, or you can focus, like I said, on pre-planting and just do that way. So everything that used to be like right in your face on the previous iterations, we've now kind of separated out so you go through a proper procedure. But what's important here at the risk assessment tab is we have new features that are put right up at the top so it's easy for you to access. The first one is looking at a parameter file. What that means is basically every time you go back to this website, you have to input all the information in one by one again. And that takes time. We all have busy schedules. So that's not the most intuitive part that we can have in our platform. So there are ways to download the what you input. And so it'll just kind of download as a CSV file or an Excel file, and you'll be able to save it and make changes even just here offline. It gives you a default parameter name, which you can change. But what it does is it tells you kind of like what section, the control point, the category, so those are the subsections, and what we've called it in the tool, and any inputs you've put in. The comments field is there for a holding place so that we can insert those other mitigation measures or refine this to meet the needs and requests of the industry. But it's very simple, and so that all we have to do is go back here and upload it, and it'll populate everything that you put in previously. And so then you can look back and see if I change one little thing for a contingency plan, or what if I want to address this particular intervention, how does that change my risk? And you can save a bunch of these and use them as a reference. Okay, let me skip forward. The other feature is a risk assessment report. And so this will generate a PDF document of basically everything that was put in here. It's not something that you can upload, but it's something that might be useful to hopefully pair with a certification program or just your management planning. So right now it's it has a very simplistic name. You can always change it, Phyto Risk Report, and it's a PDF document that we're adding to, but it'll tell you everything that you put into the model and feedback the risk assessment. So there are more features we could add here, but that would be something we would like input or feedback from the industry if this is useful. So it's a really neat feature. So those are two new things that we wanted to address in the next platform, but you still have your risk assessment. And so you still have the distribution of risk. In this example, I didn't put anything into the settings, and so nothing's known about it. So you're going to be at high risk of contamination. So you still have the node network. I just kind of left it in the side because I enjoy having this. It's very intuitive to me, but it's not completely necessary, but it gives you that kind of pathway version. And then down below, there is a similar framework of that table of the outputs so that you quickly can see all in one place what you put into the parameters on the previous tabs and whether or not that's what you had in mind or need to go back and change something. Yes, I'll quickly go through this. There are in the info tab, it's just more information about the model, some resources that we plan to keep. So if there's disease guides that we can put in, we'll put in different timetables of the updates and information about the model and different things in here. So that's kind of a work in progress, but I think it's a neat thing and an important thing to pair or partner with the platform. Okay, now I'm trying to quickly go through this before I lose all of the time, but we'll do a little bit of demonstrations. So this is going to take me a minute to switch screens here. But right now, this is the current link for the platform. It's not hosted fully. It's not an easy link to remember, and so we're working on getting the a domain name and a host for this so that it's easier for you to connect with. But for right now, and if Wakey's there, if you can put that in the chat, or I'll leave this up for a few minutes while I try to switch screens. I also feel like I've been talking for a while, so if there's any questions, feel free to ask. Stop. Okay, my internet is definitely slow today, so and as usual, any live demonstration usually has a few kinks, I guess, or hiccups. So yeah, the link is up above. We will definitely share this after the session here so that you can access it before we put it on a more permanent host. So please, I hope you find the time to kind of play around with it and interact with it and see if you have any feedback or questions or concerns or things we can do slightly differently to help improve the experience overall. But as you can see, yeah, my screen's sharing. I made a mistake last time, but not this time. You can kind of interact with each one of these. So if I wanted to skip over to post-harvest, it would jump me to that area. But let's start back at the beginning at pre-planting. So I can go with my original. I'm in an area that's very vulnerable or high risk for introduction or invasion into my production site because there's been a pest presence in my neck of the woods, or or even a history of contaminated seedlots coming from that area. So I do have this, but one thing I want to do to mitigate that is before I even start my production, I can go in and say, yes, I'm testing the seed before I implement it or put it into my production process. Usually when you have a high pest population, climate tends to be very favorable if that's already been well established. Climate conditions tend to go hand in hand with population dynamics. So we could make this very unfavorable, but those two are somewhat linked. So you have to use your own subjectivity when answering these kinds of questions. But we can say we've kind of ensured that we have good soil. We have very good water source quality because we've implemented a cleaning system or an irrigation system as opposed to using unfiltered water from some other local source. But as you can see, we can have all of this information like put in as we go through each individual scenario. And the other thing to keep in mind, yes, there's only two things I consider as a modeler in the pre-planting phase, because this is the information that's available to Wakey and myself to feed into the model. There are other things we could potentially consider or look and investigate more about the testing that was done on the seed, and inputting, say, these mitigation measures to adjust or correct the risk distribution that's associated with this variable. So these are kind of suggestions at this point of a direction that we can go, and how to incorporate these things in, because with soil we can look at a substrate or some other treatment, or there's some other inspection in place that we can kind of consider to correct for the different parameters that we have already defined in the model. We can then go to the site preparation, and the first one is kind of the site isolation. It's looking at, let me move this out of the way, the abundance of nearby alternative hosts, and whether or not that's under your control. So very high means that there's a lot of alternative hosts or weeds or something that's not managed by you in a very localized version. This is something, as I mentioned before, just like with pest population, we could potentially quantify this a little bit better. You could address what's your proximity to nearby hosts versus can we just categorize it by low, medium, and high. So we can input that information. It all depends on if that's easily intuitive or for the seed company to use. For the site type, we're just looking at open versus covered. I'll say mine's an open field. And my cropping system we'll go with neutral just to be a little bit different. Mainly because I'm not entirely sure what crop rotation I've last done, but that's me. I'm not a seed company and a manager of a production site. But we can talk more about, say, the actual crop rotation, or if there was any fallow period, or what kind of systems actually in place to help adjust this for what actually gives me that quantification of risk in the end. And then down at the bottom, we can move to the next and start answering information about what's going on in the pre-harvest phase. So I'm just going to quickly, because I'm running short on time, to kind of start putting in some information. I'll say very rarely, because I trust my personnel, even though I put in a poor training program. The buffer management and the site inspection, there are ways to, just because I'm here, I'm going to point it out. There are ways to break this down into quantifications about what's our kind of scouting frequency, how effective are our surveyors, do we remove any unhealthy or diseased plants frequently, and then if there's any kind of treatments along a buffer. These are things that can improve or refine the model, but in its initial development, this was how it was designed. Let's have a hygiene program. Here's some efficacies that we can address and say, we regularly sanitize our equipment. but my employees, because they were not very supervised and don't have a quite robust training program, I maybe not trust them all the way to have the proper hygiene quality all the time for their clothing, gloves, and that sort of thing. Um, we can ask or refine this for more uncertainty. I'm just going to answer that for this. Into these parameters, but for the initial demonstration and use in seed companies and that sort of thing, it's easy to start in this simpler kind of mode, and then add and continue to add to it as users learn. So let me just occasionally, I don't have to put information into all. I definitely recommend that you fill out completely to have the most proper and robust risk assessment. That's the only way it'll work if we want to pair this up with management programs. For the sake of time, I'm going to skip the seed health testing, but you could definitely play around or look into these fields. So let me turn that back off and go hopefully to the next part. So I didn't put information into everything, and this is a general pest, so I do have a wide range of expected or estimated phytosanitary risk. I've definitely lowered it from those static shots where everything is mostly 100% risk. So I'm looking right at about a median risk of 6.8% of contamination. So there is my interquartile range is quite dramatic because of the lack of information I've put into this. But here's my network. You see the black nodes I didn't turn on, or it's missing, or it's unknown information. I have a few red and yellow areas that I could go back to and address to try to improve. And then, like I said, here's the table of everything that I've put in. And you have the options to download, upload, and do all those sorts of things. Yeah, let me keep skipping through. So again, resources, there's contact information about the modeling team, our collaborators, and ASTA for different ways to work with it. I want to click it, but I don't want to crash and want to finish to get to the discussion part. So I hope this was somewhat helpful, or it gives you a little bit of an opener into the online platform. Let me switch back. Stop share. Okay, yes, I think 5 minutes left, so I want to open the floor at some point. So let's go straight to a discussion. I can share some of this information with you all so that you can read through it, but it's just a wrap up of how the model was built. We had an initial focus. We're using expert experience to input or populate the model, and we continually need to refine it as more information becomes available, whether that be just more knowledge and experience in the field. And then we want to keep the online application up to date with new features. So to open kind of the discussion is looking at next steps, so possible extensions. I quickly went through a lot of different things, but one of the main things we can continue to do is expand the variables or components to ensure completeness and enough detail to partner with certification and management plans. So we can incorporate a little bit more distinctly what are variables and model components in each of these stages. As you've seen on the slides, the storage and distribution section needs some more feedback and information to really make available to you all. So there are places where we want to continually improve and refine the model. Another extension that we need to do, or I think would be really helpful for the seed companies, is to kind of showcase the sensitivity analysis on the platform. And this will help to kind of rank in a quantification kind of mode the interventions and the practices. So what that does is it highlights the relative impact for each of the variables. So then when you're doing those contingency plans or what if scenarios, it may highlight or clue you into something that would give you, say, the biggest bang for the buck. we also want to consider those correction factors. Some correction factors could be detectability or feasibility, but also some of those mitigation measures that we listed in the pre-planting section on the online platform. And then finally, the whole concept at the end is really to be a lot more linked or intertwined with your management planning and those certification programs.
All right, Drew, we have a couple of people with some questions. So if it's okay with you, I might go ahead and let Dr. Gary Munkle talk and then have another question from the group.
Okay, sounds great.
Gary, go ahead.
Hi, Drew. It's Gary.
Hey,
How are you? So predictably, I have a comment about the seed health testing part. So I'm not sure exactly how you changed it because, yeah, you mentioned that you had in some way removed it from the model. And I think I know what you mean there in the sense that it doesn't affect the physical condition of the seeds, but it's, like you say, it's a tool for removing contaminated seed lots. So I guess from my point of view, that's a pretty important component because what we're really interested in at the end of the day is the risk that a contaminated seed lot would enter the market. And that's where the seed health testing component can have a big influence. So for example, if you had a testing method that you use and it has like a 1% false negative rate, that would mean to me that the risk of a contaminated seed lot entering the market would be at the most 1%, and regardless of how contaminated the seed was before that. And then that false negative rate also has to interact with the initial risk that you calculated before it was tested, because if that risk was very high, then your probability of false negative is very low, and it would interact with the sensitivity of the method. So I'm still wondering, and I haven't obviously been able to play with the latest updates, but I'm still wondering if those concepts are really being captured. So can you comment on that?
Sure. No, that's an excellent comment and perspective to bring to this, because yeah, that is something that was treated a little bit differently at the beginning. But one of the things that we wanted to focus on was looking at first just the contamination of the risk of contamination in that seed lot. So you're exactly 100% correct that the seed health testing would then be reliant on what is that estimated risk at that point in the stage. So in our very, not first, but maybe our second or third iteration of the online platform, we had the conditional probability tables that's looking at kind of those false negatives or false positive rates to see if the seed would truly be excluded from the system. That's not available in the platform right now, this version that I'm showing today, but it's still within the model. I think what I ran into with some of the different discussions was to start kind of small with where the feedback was about how they wanted to visualize or inspect or their phytosanitary risk. But that's something that needs a little bit more not information, but some other pieces to partner with it on the online platform so that it's explained correctly. So there's a lot of different ways you could take that conditional probability table and how it interacts with this distribution that's online. So what will end up being is another section, another tab that shows those two linkages, but it just needs to be explained better than I've done in the past on the online platform. But it's not something we've taken completely out of the model. It's just in this first general pathosystem framework that we've kind of shifted it to not the focal point. And another reason for that would be kind of the budget. If there's, I believe seed health testing is quite expensive. I could be wrong. Again, modeling framework here. So I didn't know that everybody was kind of leaning towards getting things tested. That's something that I can definitely be corrected if I'm wrong. So that's kind of why there's been a switch in some of the focus. But I think what we'll do is have, like I said, another section on here that shows those two interacting. But I need like a paragraph to explain what the contingency table, not conditional probability table means and how that affects the risk outputs that we currently have that are front facing. I think what we can do is set up another discussion between you and I and Wakey and Rick if you want to kind of nail down the intended direction that we're headed to make sure that that's reasonable. But I do think it's a critical component, but so it's still there. It just is not available yet on this version that's online. So I hope that addresses somewhat of your comments for this quick short session that we have today.
Yeah, thanks for that. Yeah, I think there's a lot more to talk about, but as far as the cost concerns, that's highly dependent on which pathosystem you're talking about, and also the intensity with which health testing is used also depends a lot on the pathosystem. So we'll leave that for the next discussion, but thanks.
Sure.
All right, well, we're running a little bit over, but I want to get to the one other question we did have. So Maria Sanchez says, this tool looks very nice to learn and find measures that industry could implement to manage risk of introducing a pest. However, I'm interested to know if there has been validation of the risk, such as pilot, that the model really produces measures that minimize or reduce the risk and in which percentage.
Okay, so let me try to address that in two parts in a condensed version. So the model has not been completely validated. We are still getting feedback for some of the particular pests that we've built for. So say CMM or CGMMV, we've gone back and gotten some feedback about the relationships of the model design, but the way to validate it is to continually assess experts in the field through their own pilot projects as well, but to look to see where that is, because there are constraints on our modeling design because it's built by expert experience and knowledge. So if there needs to be corrections or different inputs put into the system, that's where some of the validation is insufficient, I'll say. So it's a model that continually needs to be in a learning mode and updated as that information gets put in. The other part of the question, let's see if I remember what it is as I lost my train of thought, was to look at the impact of individual management practices or intervention strategies. So please correct me if I don't address it completely. But if you're looking at that, that kind of goes hand in hand with the sensitivity analysis that I think is very valuable. So what that would mean is that it would look at which strategies or practices or mitigation measures based on the information we've gotten from experts actually is the most impactful, and how influential or how intensely is that impact felt in the system, whether that's in a pre-planting phase or harvest phase or throughout the whole pathway. So those are two things that can be addressed through continual feedback from experts and adding that sensitivity analysis to the platform. So that's my long-winded answer. I hope I got to every part of the question.
Hey, Drew, this is Rick Uncle. Just a quick comment. In the refresh manual now, there is an annex tool in the manual, and it has come up with a chart that identifies pest categories and then the general management practices that can be implemented for those pest categories. So we've been talking a lot about how to deal with the hundreds and hundreds of pests in particular system, production system. But maybe we can go back and look at that tool, because it does categorize pests down to a limited number of categories, and then it links up the various general practices that can be used to manage those pest categories, like viruses or water transmitted pathogens and so forth and so on. So that might be something we can also take a look at that would make this a little bit more widen the use of the model a bit more.
Yes, I think that's a great possibility for the kind of extension. Yes, I believe Refresh has done quite a bit of work in the past. And so there's definitely a lot of different pieces, and it would be nice to be able to try to integrate those different things. Yeah, because the focus here on this part is just trying to get a quantification of that risk. So I think that would be helpful to partner up or couple some of that information together if there's more overarching categories or pieces that are missing from our side on the risk quantification. Any other questions, comments? Yes, I definitely ran over time, so.
This is Rick again. I just say all the contact information for the participants in the development of this thing are available now. So anytime you have any questions or concerns or comments, please feel free to contact Drew directly or any of us that are listed here. We're more than willing to help keep this project moving in the right direction. So with that, Drew, I thank you so much, you and Wiki and all of the others that have been involved in the development of this model. I think we're just at the very beginning stages. The more it's used and the more pathosystems can be ultimately put into the system, the better it's going to be, the more useful it will be, and the more accurate it will be as well. Just one other comment there. Drew and Wiki have put together a streamlined process to collect expert opinion to develop information on additional pathosystems. So with that, I think we need to also take a look at how we can continue to work together to add data and information into this model. Thanks again.
Okay. Yes, thanks for the summary and wrap up. I appreciate everybody hanging in there with us today for our longer than 1 hour session. But yeah, feel free to reach out to any one of us. We'd be happy to address any more questions offline as well. So thank you for hanging in there, participating.
Thank you. Appreciate it.